Alright, so this is my first video for the week 4 explanations. So in this problem, there's a centrifuge that rotates at 4,000 RPMs. And we need to find the acceleration of a test tube that is 10 centimeters away from the axis of rotation. So the equation that I used for this is the linear acceleration, which is equal to the distance between the object and axis of rotation and the angular velocity squared. So before we go on and solve this problem, we need to do a quick unit conversion for the angular velocity and turn it into radians per second instead of revolutions per minute. So first, to turn it into radians per minute, multiply by 2 pi, because one rotation is equal to 2 pi, and that turns it into radians per minute, and then just divide by 60 to turn it into radians per second. So it turns out to be 418.88 radians per second for the angular velocity. So now that we have that, we plug it into that first equation we used for the linear acceleration. So the distance between the axis of rotation and the test tube was 0.1 meters, and the angular velocity was 418.88 radians per second. So you square that. And finally, to get the acceleration from the test tube and the 10 centimeters away from the axis of rotation is 17,546.05 meters per second squared. And for the second part B, we need to find the acceleration, the magnitude of the test tube that's dropped from a height of 1 meter, and it stops in a 1 millisecond long encounter with the floor. So if we go back here, there's some equations of motions that we use to solve this problem. So the first equation of motion, which is the final velocity, is equal to the initial velocity plus acceleration times time. And the third equation of motion, which is final velocity squared minus initial velocity squared, which is equal to 2 times acceleration times the distance. So in this problem, for the second part, the initial velocity is 0. So we're going to get final velocity is equal to acceleration times time. And since we're solving for the acceleration, we're going to isolate A, and it simplifies to become the acceleration is equal to the final velocity over time. So now that we have that equation, we're going to use the third equation, the third equation of motion, to solve for the final velocity. So the distance that the test tube fell was 10 centimeters or 1 meter, and that initial velocity was 0. So to get the final velocity, you just after you put in 0 for the initial velocity, you square both sides to isolate for the final velocity to get 2 times the acceleration, which is a gravitational constant, times the distance, which was 1 meter. And that turns out to be 4.4272 meters per second. And then that gets plugged in back to the equation, which was originally the first equation of motion, with A isolated, to get A, which is the acceleration, equals the final velocity, which is 4.4272 meters per second, over the time, and then counter with the floor, which is 0.001 seconds. And that turns out to be 4,427.2 meters per second squared.